Hey everyone, welcome back to RE7. My name is PeterRae, and today we are diving into something a little different but incredibly powerful. If you've ever wondered how real engineers design hydraulic systems for industrial robots, heavy machinery, or precision equipment, this video is for you. Because today we're going to learn how hydraulic engineering meets Python programming and how you can use code to think, calculate, and design like a real engineer. You don't have to be a pro at math. You don't have to be a programmer. You just need curiosity, and Python will do the heavy lifting. So grab a notebook or open your IDE, because by the end of this lesson, you understand how to use Python to calculate hydraulic cylinder force, bore size, valve flow, pressure drops, and even pump sizing. And yes, this is real engineering used in robotics and automation today. Let's get started. Hydraulic engineering is one of those fields where you deal with lots of numbers, lots of relationships between pressure, flow, force, and velocity. Engineers have formulas for everything, but no one wants to calculate them by hand every time. That's where Python comes in. Python is not just a programming language, it's a calculator that never gets tired. It's a simulation tool. It's a digital lab. And when we combine hydraulic formulas with Python functions, suddenly a 10-second script replaces an hour of manual calculation. Students understand the relationship between variables instantly. We can test multiple scenarios effortlessly. And most importantly, Python gives us the power to design a complete hydraulic actuator with confidence. In this lesson, we'll base our example on a real engineering scenario. A robot arm must lift 3,000 kilograms using a hydraulic cylinder. We need to find cylinder bore, rod diameter, flow requirements, pump displacement, valve size, hose pressure drop, and Python will calculate each step. Imagine you're designing a hydraulic actuator for a robot. The robot must lift 3,000 kilograms, or about 29,430 newtons of force. But engineers always include a safety factor, often 2x, so we design for nearly 60,000 newtons. The system pressure is 250 bars, which is common for robotic hydraulics, especially if we are using a high-performance pump like the Hengli HP3V series. Our target cylinder speed is 0.2 meters per second, which is fast but realistic for a robotic linear actuator. Now, how do we solve this? With Python. Let's go step by step. Getting input from the user. What this means? The program asks the user to type in actual engineering parameters. Example: load kg, pressure bar, cylinder rod diameter, hose length and diameter, pump speed RPM. By using float, Python accepts decimal values, for example 12.5. This makes the program interactive, perfect for students. If you are a student who is not yet fully comfortable with the underlying physics formulas, you may ask the AI to explain the meaning, purpose, and derivation of any equation used. In fact, I relied on AI to review and validate all of the calculations before integrating them into the Python program. Explaining the calculation section line by line. What this does: takes the load in newtons, takes the system pressure in bar. The function calculates bore, m the cylinder bore diameter in meters, area the piston area in square meters. Engineering meaning: using the formula equals A equals F divided by P. Python finds the minimum bore size needed to lift the load safely. Cylinder force check. Force area check equals cylinder force bore. M times 1000. Pressure bar. What this does: converts the bore from meters back to millimeters, uses the pressure again to compute the actual cylinder force. Engineering, meaning this line recompute the force to confirm the bore size works. It is a sanity check to ensure no calculation mistakes. Flow required for cylinder speed. Flow equals flow, required area, desired speed. What this does, takes the piston area, takes the desired cylinder speed millimeter per second or meter per second. Engineering meaning uses the hydraulic flow formula. Q equals A times V. This determines the flow rate liter per minute needed from the pump and valve to move the cylinder at the required speed. Valve sizing. Valve flow valve dP equals valve size flow pressure bar. What this does? Uses the cylinder flow, uses the system pressure. The function return valve flow. Recommended valve rating with safety margin. Valve dP. Pressure drop across the valve. Engineering meaning valves must be sized slightly bigger than required flow to ensure smooth motion, fast response. Low heat generation. The function calculates the correct nominal valve size. Prior to specifying the input and output parameters, it is essential to establish how to properly communicate with the AI during each stage of the design workflow. This ensures that the resulting hydraulic model is computationally accurate and that the Python calculations align with the required performance criteria. At this point, we will insert the full AI-generated Python script to proceed with testing. Why teaching hydraulics through Python works? 920. Here's why this lesson method is so powerful. Students learn engineering by doing. They see real equations produce real numbers. Python makes abstract concepts visible. You can plot pressure versus flow, bore versus force, and more. They build confidence. Designing a hydraulic actuator feels like magic, but Python demystifies it. They gain employable skills. Industries value engineers who automate their calculations. You bridge theory and real system. Instead of memorizing formulas, students are designing robot parts. And that's the future of engineering education. Alright everyone, that wraps up today's deep dive into how Python transforms hydraulic engineering. If you enjoyed this lesson, hit the like button, subscribe to RE7, and drop a comment telling me what hydraulic or Python topic you want next. This is PeterRae, and I'll see you in the next video. Stay curious, stay creative, keep advancing your engineering skills. Your feedback is appreciated, so feel free to like, comment, and subscribe. Thank you.